Slope can be 0, positive or negative, right? Like going
Yes,
up
sir.
is positive, going down is negative. Similarly,
Yes, sir.
area can be positive, 0 or negative. 0 means the curve has to touch the x-axis because area is between the curve and the x-axis. The only way to get 0 area is the curve will touch the x-axis. Positive area means the curve will be above the x-axis, so the y will be positive. That you can understand by area of a small part is y into dx, right?
Okay.
And
Okay, sir.
dx is always positive because we are going from uh, increasing x direction. We are going in this direction. In this direction, dx is always positive because dx is the final x here, xf minus the initial x, which is always greater than 0. So if y is positive, area is positive. If y is negative, area is negative. Okay, so for this small strip here, y is positive, so area is positive. And this strip here, y is downwards or negative, so area is negative. So using this thing, we can also understand why the derivative of this one, integral of cos x is sin x, right? Because here, this red curve is the cos curve. This one, this is cos x. Okay, and if you take the area under this cos x curve, I'll get this answer, which is sin x. So here you can see as I go from here to here, from here to here, area is positive. So the area will keep on increasing. So the value of sin x will also keep on increasing from here to here. After that, if I go here, I'm adding the negative area. So after this point, the area will keep on decreasing because the area from here to here, for example, is this much of positive area plus this much of negative area, right? So this negative will cancel this much of positive area here, and whatever the remaining positive area will be the value of this sin x. So here you can see as I keep on including more and more negative area, at this point, the amount of positive area and negative area will be same. So the value of this sin x function will be 0. And from here to here, the area is negative, so the value of the sin x is negative. And up to this point, the area is negative, so it will be maximum negative. So I'll get maximum negative value. After this thing, I'll add positive area to the negative. So, but this sum will still be negative because negative area is more. And at this point, the amount of positive area and negative area will be equal because here's negative area, here's positive area, which is same. So they'll cancel to give me 0 value of the function, which is the sin x. Okay, another example is integral of sin x is minus cos x. No,
Yes, sir.
integral of sin x dx is minus,
Minus cos x.
yeah. So that also we can understand with this area interpretation. So sin x function is like this. So suppose I start from 0. Okay, area is positive. It's keep on increasing. Still, it will keep the area will increase up to this point. After that, the area will start decreasing. Okay, so if I draw cos x, it will not match with cos x. See, cos x is looking like this, right? Cos x, the point should be this is one point. You pass through this point, and cos this one is cos 180 is minus 1. So it's like this. So this is cos x. So this sin x, this area is constantly increasing, but cos x is decreasing. But if you take minus cos x, then it will match. Minus cos x is root of this blue curve. This is minus cos x. So area under the sin x is matching with minus cos x, not plus cos x. I'll explain again. So this is the red curve is the sin x curve. This one, this curve. So if it go from 0 to say up to 180, the area is constantly increasing because I'm just adding positive areas. So that thing, if I try to match with cos x, which is this function, which is not matching because it's decreasing. But if I take minus cos x, this is the function which is constantly increasing. Okay, so that way I can also figure out that there has to be a minus sign here. Because integral under the curve sin x is matching with minus cos x, not cos x. So this is geometrical interpretation of integration, which is opposite of derivative. In the sense like geometrical interpretation of integration is integral under the curve, but integral of this as a function which is just reverse of differentiation. Suppose I want to find integral of integral of 1 by x dx. What is this function? Remember?
Integral of
Ln x.
1 by ln x
Yeah. The
or
proof of
log
this
of
is,
x.
yeah. The proof of this is if I differentiate ln x, I'll get 1 by x. d by dx of ln x is 1 by x. So from this, I'll get this result. There is no independent proof of integration. Okay. Integral of 1 by x dx is ln x. The proof of this is if I differentiate ln x, I'll get 1 by x. Okay. So
Integration is the exact opposite of differentiation.
yeah.
Okay.
So if you want to find integral of x raised to the power n, I have to differentiate which function to get this one. So this the answer is x raised to the power n plus
X of
by n plus 1 plus a constant c, because derivative of constant is 0. So to prove this thing, I just have to differentiate both the sides. So if I differentiate the right side, I'll get n plus 1 into x raised to the power n, and there is n plus 1 in the denominator. So these two will cancel to give me this will cancel. Derivative of constant is 0. Because as I said, this line, the slope is 0, and also this line, the slope is 0. All horizontal lines. This is the x-axis. Okay, so this is the line x equal to c1. This is the line x equal to, sorry, y equal to c1. Y value is constant. This line, the equation is y equal to c1. This is y equal to c2, some other constant. But differential of this constant line is also 0. So the slope of this line is also 0. Okay, so derivative of constant is 0. Because the horizontal line. Understood? See, this is my x-axis, y-axis. I'm taking a horizontal line. Just a minute. If you take this, say, horizontal line, the slope of the line is 0 because it's not going up or going up. Same thing is true for
so
this line also.
it's not increasing, so slope can be 0 now.
So this line also, which is parallel to this x-axis, this also slope is 0.
Okay.
This line also, slope is 0. Even this line, if we take a horizontal line in the negative x direction, this line also the slope is 0 because the horizontal line, but it's just downwards.
So if it is a horizontal line, then the slope can be 0.
So the equation of this line is y equal to some constant c. So if we differentiate this thing, I'll get d by dx of c is 0. Because that's a formula, or you can also understand in terms of slope. Because
That's a derivative. That's a derivative is given. If a constant gets differentiated, then 0 is the answer.
Yeah, because the slope is 0.
Yeah.
So to prove, when I prove this one, there I'll add an integration constant here when I do the integration. When I differentiate, the differentiation of this constant will become 0. So you can say integral of sin x dx is cos x. Proof of this is differentiate both the sides. When I differentiate cos x, I'll get plus sin x. That means this is true. Okay, and kinematics you have studied with the velocity is
Velocity, differentiation of velocity.
we'll come to that. First, velocity is d by how fast the displacement is changing, which is
dx by dt.
uh,
Difference in delta x by delta t.
yeah. What is the difference between delta x and dx?
Dx is difference in speed. Delta x is a change in speed.
No, delta x is
Difference in displacement. Sorry.
what is dx?
Dx is difference in displacement.
Delta x is what?
Change in displacement.
No, see, delta x is small change. Okay, d means very, 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 very small change. Very, very small. In the limit, it will be 0. In some sense, you can understand delta x in the limit, delta x tending to 0 will become dx.
Okay.
Okay.
When limit extends to 0, delta x will become dx.
See, delta x can be this much from here to here. But dx is very, very small.
Very minor deviation.
Yeah. In the limit, it is 0.
So if limit is taken as 0, then we can get dx from delta x.
Yeah. So velocity is dx by dt. Similarly, acceleration is how fast the velocity is changing. It's dv by dt. Okay. So from this, I can interpret velocity as the slope of the, suppose I have this xt curve of a function. Time versus x. Okay, so the say some body is moving, so x is constantly say increasing like this. Just for an example, let me take x equal to 2t square. So for this thing, if I have to get the velocity, I just have to take the slope of this curve. So here the slope is 0 because the tangent will be horizontal. After this, the slope will become 4t. Velocity is dx by dt. So if I differentiate this thing, I'll get 4t. So it'll look like this. So here you can see the slope is constantly increasing. Here the slope is this much. Here the slope is still steeper. Okay, here the slope is 0. Here it will be less. So velocity I'm getting by differentiating this one. So if I go in a reverse direction, I should get displacement by taking the area under this curve. So if I want to x at this particular value of time, it is this much of area. So at this time t2, displacement is this total area. So time t3, I will take the full area up to this one. So as time increases, the velocity will keep on, displacement will keep on increasing because the area is all positive. So if I add keep positive areas, the displacement will keep on increasing. So if we take this practical example, see this is the Earth's surface. From this thing, I'm throwing a ball with the initial velocity u. Okay, I'm throwing vertically up. So it goes straight. As it goes up, what will happen to the velocity? Will increase or decrease? Earth is here. I'm giving some initial velocity, say 5 meters per second. As it goes up, the velocity will become 4 or become 6.
It will decrease. The velocity
Yeah.
reduces.
Yeah, it will decrease because the force is opposing the motion. Force is downwards. Gravity force, which is force due to the Earth, force is downwards, which is opposing the motion. So velocity will keep on decreasing at the maximum point, the velocity will become 0. Okay. After that, the velocity will keep on increasing until it hits the ground. When it reaches the ground, it will become velocity equal to same 5, but minus 5. Because the direction is opposite. At this point, if it has become, say, 3.5, while going up, while coming down, it will become minus 3.5. It is same 3.5 by symmetry because when it is at this height, while going up, it is 3.5. While coming down, it will be at the same 3.5 value, but the direction will be opposite. While going up, the direction is upwards. While coming down, the direction is downwards. Okay, so for this motion, if you plot velocity as a function of time, at time t equal to the velocity is maximum 5. And the velocity will keep on decreasing until it becomes 0. At this, say, at this point, let it reach at a time, say, t, m, t middle. So this time tm, the velocity has become 0. And after that time, the velocity has become negative.
Okay. Okay, sir.
And when it reaches the ground, this thing will become minus 5. Okay, so here, yeah, here the time will be 2 tm by symmetry. Tm is the time to go from ground to the maximum height point. While coming down, it will take the same amount of time by symmetry. So the total time when it reaches the ground for the second time, it will be 2 tm. So this curve, if I take the area under this curve, I should get the xt curve. So here you can see as time increases, the area will, it's positive area. So area up to this point is increasing. After that, if I this much time, this area is negative. So area will reach its maximum at tm. So this is x value and this is t value. So at up to tm, until it reaches tm, the x will keep on increasing.
Okay, sir.
Okay. And after that, I'm adding negative area to this positive area. So it'll keep on decreasing. And once it reaches 2m, negative area and positive area will be equal by symmetry. So the total area will become 0. So at 2 tm, displacement has become 0. So this one, if you take the area under the curve, I'll get xt curve. Understood? Area, taking the area is same as doing the integration. Integral of v dt is x. Why is x equal to integral v dt? That's because v is dx by dt. Take dt on the left side and integrate. I'll get x equal to integral of v dt.
Okay, sir.
Okay. Similarly, I can also draw the acceleration. Acceleration will be constant. So this is 0 origin, and this is the time. So acceleration will be minus g. This value is g, minus g actually. And that is true, right? The slope is negative. Slope equal to negative because the line is going down, and that value is minus g, where g is minus 9.8 meter per second square. Okay, and this thing, the area under the curve is constant and it is increasing because I'm adding more and more area and it's becoming more and more negative. Starting from this thing, I mean, the area is negative,
Origin.
so it'll keep on going down. So that's what is happening.
Does it start from the origin, sir?
But here, that integration
Sir?
constant is,
Does it start from the origin?
which one? The velocity.
The line, the extending down. Does it start from the origin?
The acceleration curve?
The negative, the acceleration, negative slope.
No, it will not start from origin. It will start from
some constant value.
Yeah. See, that's because I can have an integration constant, no? No, just a minute. Velocity is integral a dt. So it is area under the. So when I'm doing integration, I'll get area under the curve. Plus, I can have a constant. Okay. Initially, at that time t equal to 0, the area is minus 9.8. So this constant should be 9.8. So that I'll get a. Sorry. So initially the area is 0 because, but I should get the velocity as plus 5. So the integration constant is plus 5. Or I can, just a minute. See, area is a function of time. This velocity I'll get as a function of time. Plus this thing, this integration constant is the initial velocity u, which is same as velocity at time t equal to 0, which is here 5. Because area at time t equal to 0 is 0 because I'm taking this area from this small strip, which is 0. Similarly, here when I do the integration, here the integration constant is 0 because the initial displacement is 0. I'll just repeat.
Yes, sir.
See, this is time, this is acceleration. What I'm saying is acceleration curves like this. Okay, this value is minus g, minus 9.8. So if you take the area under this curve, starting from this one, so for small value of t, delta, the area is this much, which is almost 0. So velocity at t equal to delta is 0 plus the integration constant, which is the initial velocity to match with the velocity curve. Okay, so as time increases, they will become more and more negative. The amount of negative area is more, will keep on increasing. So this time will correspond to the time it reaches the maximum. At this point, the area will become equal to the initial velocity u. So this u or minus u plus this plus u will become 0.
Then what about the final velocity, sir?
Final velocity, see, this there'll be a 2 tm, right?
Yeah.
Okay, so this area, so this entire negative area, which will be 2u minus 2u, because the area from here to the tm is minus u. Okay, and the area from tm to 2m is another minus u. So the total area will be minus 2u plus the integration constant is u. So the velocity at time 2 tm is minus u, this value. See, the area is always negative and its negative values keep on increasing. So initially, the area is 0, but that initial integration constant will have the initial velocity value. So it is phi. After that, the negative will keep on decreasing this velocity value. So at time tm, where it reaches the maximum height point, the amount of area under this curve is minus u. So that minus u plus this initial constant, which is u, that will give me 0. After that, it's negative area, which will keep on increasing until it becomes, this 2m will become 2u. So 2u plus u will become minus u. So at this bottom point, when it's coming back, it's minus u. So there's an interesting thing to note. Area is always negative. So as time keeps on increasing, the velocity will keep on decreasing. So that's what is happening, right? Initial velocity is plus 5. After that, 4, 3, 2, 1, 0 is the maximum point. After it becomes negative, minus 1, minus 2, finally up to minus 5. So everything is consistent. The only thing I have to put the proper integration constant value. Integration constant value should match. I can fix here. So area under the curve at time t equal to 0 plus this area is 0. And it should match with the initial velocity. So C should be u. This step, if you put t equal to 0 plus, 0 plus means just a little bit more than 0. So at that time, the area under the curve is 0. Because the area is from this very, very thin step. In the limit, it is 0. So the area is 0, but my velocity value should match the initial velocity. That means the integration constant should be u. Only then I'll get this u at 0 plus as u. Okay.
Okay, sir.
After that, the velocity will keep on decreasing because area is negative. And that's what is happening here in this curve.
Sir?
And this is how we have to understand this relation between the derivative and the integral. Okay. So in 10 cent, how much did you score? Out of 500? Your mic is off.
Sorry.
How much did you?
Yeah.
10 cent, how much did you score?
In what? In 10th standard. 471 out of 500.
470.
471.
Okay. Highest is how much?
Out of 500. In highest is SL French 96 I scored.
No. In your class.
Oh, in my class. I think 484.
Who got it?
Harshan.
What about
Harshan or Ritika.
What about Gayatri?
Gayatri, she got 482. Harshan, he got 481. Without IT substitution.
Who is the physics teacher now?
I changed schools to Perambakam branch, so for me it's different.
Which branch you have changed?
Perambakam.
Perambakam.
Yeah, they changed me to that branch. After you left, sir, Why did you like leave our school, sir?
Because your students are not behaving properly, no? They were,
IPL kids are like
they were talking in the class.
IPL kids or MPL kids?
You felt what?
IPL kids or MPL kids, sir? Yeah, like
No, even CPL was like that. IPL.
so like I liked your teaching, sir. Your method of teaching.
The teaching was fine, man. The problem was the students are not behaving properly, and that's why they were management also questioning why are the students not listening to your class.
Uh-huh. Then your question got replaced by another physics teacher at that
Yeah, he was
after
not
you
good.
left.
He
Yeah, he
wasn't good.
wasn't good. He gave like full notes. He kept giving notes. He didn't explain properly.
He was a board level.
Yeah,
That they themselves he got recruited like that only. He was a board level
yeah,
teacher.
yeah, yeah.
But after that, who came?
After that, I think no one else. I changed branches after that.
Oh, that time itself changed, is it?
Yeah, I changed.
How were the teachers in Perumbakam?
The teachers they're all right. Physics, except for physics.
Uh-huh. Your home is where?
My home is in Madipakam, sir.
But previously?
Previously, it was in Kikat Lake.
Previously where?
Kikat Lake.
Okay.
Yeah.
Okay, fine. How many students are there in the class?
Uh, till in my class or like in 10th grade. Perumbakam or like Palaram too. Which are you asking, sir?
Yeah, Perumbakam. Now you don't have any
Perum,
contact with Pallavaram, no?
I do a Palaram students numbers.
Okay. Okay.
So
Um,
like in my classroom there are like 60 people.
that's MPL, no?
Yeah, elite now.
It's called what? Elite.
Yeah, elite. It's called elite.
What happened to MPL?
Only till 10th they may call us MPL. After 11th they change it to elite aim something like that.
Uh-huh.
Yeah.
Okay, what are the best result this year? NEET?
I
Or
need
just this year?
720.
No.
720.
Okay, but to 2026 re-NEET has happened, no?
Yeah, yeah.
Okay.
I think the top score is 720. In my branch, they are conducting weekly tests. For a few weekly tests, I did good. The top score is 720 in that branch too.
Okay.
My total it was 685.
Yeah, just keep going because this is the beginning, no?
I know.
So max, how much you got?
In physics, there's no max anymore, sir. In physics, I take max.
No, no,
Like max
no.
is used for both physics and
10
chemistry.
standard you took maths, no?
Yeah,
How much did you score?
94,
Okay.
94 yes.
Uh, Science?
95.
Okay, okay. So this they are given the planner for you, right? So uh, first did you teach that NCRT stuff?
At NCRT in
No, how see 10 standard they finished NCRT first, right? Before
yeah,
going to
yeah.
but right now what they're doing in 11th standard?
In launch standard, they took units and measurements, and kinematics they finished till kinematical equations till uh, the graphs velocity time, position time, acceleration time till that they finished.
Okay.
Now they're taking instantaneous velocity that allows.
Mm. So weekly test
Like
is there, and then after the
yeah,
monthly test.
monthly test, no weekly test. Yes,
No, weekly test is there. After that, what test is there?
midterm,
Okay.
midterm and annual.
So when they will finish the 11th standard portion?
Before June, next year June before that.
No, I think that's late. They'll finish before that. Maybe in March they'll
Yeah,
finish.
April, maximum April.
Okay, after the 12th portion.
Yeah.
What about chemistry teacher?
Chemistry teacher, it's okay. Chemistry is alright.
Maths, you don't have maths, no? But what about biology?
Biology, botany, zoology, no problem.
Okay, so physics is the only problem.
Somewhat.
Right. Okay, I'll send some videos, my channel video on differentiation. Just go through it and see how.
Okay, sir.
Um,
Okay, sir. I will subscribe.
yeah.
Okay.
And I'll keep on I think the meeting will get over in 2 minutes. So my plan is to have class alternate days because you have to
When
plan.
is the next class again?
Today is Thursday, no?
Yeah.
Next will be
Saturday.
Saturday, yeah.
Okay, sir.
Saturday, same time.
Okay.
I'll keep in touch in WhatsApp.
Okay, sir.
Okay, I'll close now. 1 minute is there remaining. Fine. So that's my plan. Either you have to go inside chapters, it'll be like 2 weeks for one chapter.
Okay.
That'll be a good rate. That's
Okay.
almost same as what you're doing in the class there itself.
Yes, sir. Yes, sir.
Okay, we'll close now.
Huh?
We'll close now.
Okay, sir.
Okay. See you on Saturday.
Saturday.
Okay, bye.
See you on Saturday. Bye, sir.
Yeah, bye.